Hello everyone. In this video, we will see one of the solid design principle, Liskov Substitution principle. So what is Liskov Substitution principle? The formal definition is, if S is a subtype of T, then objects of type T may be replaced with objects of type S. In simple terms, functions that use pointers or references to base class must be able to use objects of derived classes without knowing it. What should derived or subtypes adhere to? Basically two things: function signature and behavioral conditions. As a part of function signature, you can send a derived object where base is expected. Similarly, you can return a derived object where base is expected. This is called contravariance and covariance in short. You can read up more on this in internet. Also, if your function signature includes exception, then you cannot throw different exception. At the most, you can throw a derived exception. As a part of behavior, you cannot make the preconditions strong and postconditions weak. Also, the invariance must be preserved. In addition to this, if there are any historical assumptions, then the derived type cannot break them. I am not going to explain these things in full here. It will become too theory. You can read up the theory in internet or a textbook. But let us look at a real world example. Imagine a school management system. A school that has some actors like teaching staff, cleaning staff and security staff. Each of the staff can access the school facilities like library, classroom and canteen. Let us consider some use cases here. The library and classroom locks the user entry and exit information using the ID card. They can buy food items in the canteen and the amount is charged to the user ID card. Now we have a new actor called visiting staff who also needs access to these facilities here. But the visiting staff cannot access any of these things as of now. So let us see how do we handle such a scenario in the real world. One way is to bring in a change in the system, that means in library, classroom and canteen, and handle this special case. But this is very hard. Each department has its own rules and breaking them and then re-implementing will be costly. Another option would be we link the visiting staff to an existing staff, but we cannot send the regular staff for such a work. It will disrupt the regular work. Let's try another option now. We give a visitor ID card. This card works in all our systems and the visitor can independently access the facilities. The problem is solved without modifying our entire system. You can see until the visitor didn't abide by the rules of being a staff, the visitor couldn't be accommodated in our system. When you say the visitor is a staff, the visitor should have the access card. This is an assumption about staff in our system. We cannot break it. This is what is stated in LSP principle. When you classify an object as a kind of an abstraction, the object should abide by all the rules of the abstraction. Now let's try to implement this in software. We see our system actors have some common traits. We try to identify that here. Let's call it as staff. We have three concrete implementation: teacher, cleaner and security. We assume as staff will have name, role, whether active or not, enter some entry and exit log and accept some expense charges. And we create our systems around this abstraction. The system can be expanded without modifying it. This is what we called as open closed principle. Let's look at the code and the initial version. Here is the software example. Let us look at the code base. So basically I am trying to implement the same thing in code. So we have our system which contains, for example, canteen, classroom and library, the facilities. Then we have a staff card. Then we have three actors, cleaner, security and teacher, who are inheriting from staff. Let us look at the code. So let's start from the basic abstraction staff. So a staff has name, roll number, then is active. We provide methods for logging the entry and exit, pretty straightforward things, and one method which is to charge the expense. This we want the derived class to implement. And basically this method, you can see we just give an amount and we expect this method to charge. We don't want any bool or anything where we say charging failed, nothing like that. If I say the amount to be charged, it should be charged. Then we have, let us take the facility. So you can see library has enter and exit methods. Here I'm not implementing everything for the sake of explanation and simplicity. Only the essentials method I have implemented. So entry and exit logs are entered here. If you look at the classroom, again similar methods are there. Canteen has a method to charge the staff. So if you give a staff and then amount, then typically it will check if the staff is active and then it will make a charge to the staff. All simple things. Now let us look at one of the actors. So you can see we have a teacher class which inherits from staff, and we have the name and an ID card which is provided to the teacher. So we take some of the information from the ID card like roll number and is active, and other information like name we store directly here. And we provide the implementation for charge expense, where we take the amount and then we add the amount as debt inside our card. More or less all are similar, nothing much. Let's look at the program class. So we create a set of staff like one cleaner, one teacher and one security. Then we create a set of infrastructure like canteen, classroom and library, and then we try to use them and see what happens. Let's run the code. We can see each one's card is being charged for the expense. Entry information is logged, exit information is logged, everything works fine. Now we have our scenario, a new entrant called visitor in our system. How to include the visitor in our solution? Either change the system to handle the visitor as a special case. That means modify classroom, library and canteen, but this will break OCP. And also when you want to add further things, you need more such modification. This can create the code a bit complicated. Or make the visitor as a kind of staff. Let's look at the first version that breaks LSP. Now let's look into the scenario of visitor. You can see we have a visitor class here in our actors. Now let's see the implementation for visitor. So as I said before, one way to include the visitor in our system is to go and change, for example, these infrastructure classes. Like for example, in canteen you come and then here you check, or you provide one more method which says charge visitor, and then you add the implementation there, and go to classroom and then here visitor enter and visitor exit, things like that. These things will really make this class more verbose and more complicated. So what we say, let us make visitor as a staff and we treat him as a staff, so that visitor is a staff, and then let's try to implement. You can see here we are saying we don't know, there's no roll number for a visitor, right? Because a visitor comes temporary, he's not a permanent member. So we try to give something like -1, and then we say visitor is always active. So we don't say visitor has any issue. Name of the visitor is fine, we get the name of the visitor. And when we want to implement charge expense, we can clearly see we don't have any means to charge the visitor because we don't have a card, we don't have a means, and we say visitor couldn't be charged here. So now when you try to run this program, let us say it's running, you can see all others are being charged, while when it comes to visitor I don't have any means to pay. And similarly entry and exit works because those methods are implemented, but when it comes to payment we skipped this altogether, and then now we cannot really make a payment. So this is a violation of Liskov substitution principle because we told that visitor is a staff, but then when implementing all the rules of a staff we are ignoring some particular things. Here we have weakened one of the, I would say, method here where we provide no implementation, or worst case we can also throw some exception, not implemented or not supported exception. Even that is a violation of Liskov substitution principle. Now let's ensure the Liskov substitution principle is adhered to and refactor the code and implement the visitor without breaking any assumptions from the staff. So now if you see we want to really solve this problem, so we create a class called visitor card. So the visitor card has a roll number, is active, date, something similar to the staff card. But normally what we do is a visitor card has a departmental ID as roll number. So whenever a visitor is charged, a department really picks up all this date and then makes the payment. And also a visitor card is always active, it never goes out of active, and also has a 0 date to start with. So we create a visitor card and then we change the visitor class to take the visitor card now, and we also provide proper information. So you have a card, you take the roll number is active from the card and you preserve the name, and when charge expense is called for, you make a charge to the visitors card altogether. Now when you try to run the application, you can see the visitor card was charged with 10 and then the date went to 10 actually, and visitor was able to live inside our system without breaking any of the rules. So this is an example of how, for example, often Liskov substitution principle, if it is broken, what happens, and similarly if you adhere to the Liskov substitution principle, then what happens. Whenever you design a system with a open close principle where it is open for extension and close for modification, you would definitely require to implement and adhere to Liskov substitution principle. Thanks for the attention. See you in some other video.